Now, this video discusses about what we call as the energy Zeronth law of thermodynamics and also the temperature scales. Now, what is the energy? If we say energy, that is the ability to do work. That is what we call as the energy. So energy is said to be the ability of a system to do work. So we have several forms of energy. We have what we call as the kinetic energy, and we have what we call as the potential energy, and we also have what we call as the chemical energy, and we also have what we call as the electric energy. So we have several forms of energy that you can come across with, but for the sake of interest, let's just have to concentrate on the two forms of energy, that is the chemical energy, that is the kinetic energy, as well as the potential energy. Now, on the kinetic energy, this is the energy associated with the motion of the particles of a system. So this is the energy associated with the motion of the system's particle. That is what we call it as the kinetic energy. And how about the potential energy? Potential energy, it is the energy of a position. So this is the energy of a position. This is the energy of a position, that is. And some books, they call it as the energy due to the height. That is what they call it as the potential energy. Now, for the sake of our interest, our discussions are based on the thermodynamics. So if we say thermodynamics is the study of the heat transfer, that is what we call it as thermodynamics. It is the study of the heat transfer. It is the study of a heat transfer. It is said to be the study of heat, it can also be said to be the study of the heat transfer. Whatever can be, but that is what we call it as the thermodynamics. So understanding of the concept of the thermodynamics, should have to begin with understanding of what we call it as the internal energy. So what is the internal energy of a system? Internal energy of a system. Now, let's say we have a system. Let's say this is a typical system. And a system is made up of the particles. Let's say these are the system's particle. And should be that. Let's say these are the system particles. And it can be that. And this is, we call it as a system. Now, this system contains what we call it as the internal energy, which is symbolized as U. Now, the internal energy of a system, it is the energy due to the kinetic energy and plus the potential energy. So, as far as the system is concerned, what is the kinetic energy? Now, if we say kinetic energy, it is the energy due to the random movement of particles of a system. That is what you call it as a kinetic energy. So it is the energy due to the random movement of particles, or it is the energy due to the vibration of the particles system about their fixed positions, or even if the particles are changing positions, they say to possess what you call it as kinetic energy. So kinetic energy, it is the energy of a movement, or can be given as the random movement of particles. Energy due to the random movement of particles. Random energy due to the random movement of particles. That is what we call it as kinetic energy. And how about the potential energy? Now, the potential energy of a system, it is the energy due to the position of a particle and also the interaction of the particles. That is what we call it as the potential energy. In other words, it is the energy of the forces in which the particles are interacting together with. That is what we call it as the potential energy. Now, the summation of these two energies corresponds to what we call it as the internal energy of a system. So, if the kinetic energy of the system increases, it means the potential energy, it means the internal energy of a system also increases. If the potential energy of a system increases, it means the internal energy of a system also increases. But now let's see what actually causes the increase in the kinetic energy of a system, and also that is the potential energy of a system. Now, if we apply the heat to the system, what happens is that the particles will gain more kinetic energy. Then the particles will actually start vibrating about their fixed positions, and even they will start moving randomly at a high speed. If that is the case, then it means the kinetic energy of a system it means the kinetic energy of the system is set to increase. And in that case, it means the internal energy of a system will also have to increase as well. Now, if the system particles has actually strong intermediate forces, and that corresponds to the increase in the potential energy, thereby increasing the internal energy of a system. So keep that in mind. Now, what is the measure of the internal energy of a system? So the only quantity that can be used to measure the internal energy of a system is said to be the temperature. That is the measure of the internal energy of a system. That is the temperature. So a system with more internal energy, it means that system has more actual temperature. A system with low internal energy, it means it has actually a less. It means the system has low actually a temperature. So which means you should have to understand that high temperature corresponds to high internal energy. Likewise, the low temperature corresponds to the low internal energy of a system. So keep that in mind. So if this is the case, then what is the temperature? So a temperature is said to be the average. It is the measure of the average rate of change of kinetic energy of a system. That is what we call as a temperature. So a temperature is said to be the measure of the average rate of change of kinetic energy. That is what we call as the temperature. So that's the definition of the temperature. Now in this case, let's say we have two objects. This is, let's say, object A with, let's say, a temperature given as 20 degrees Celsius. And let's say we have another object. Let's say this is object B. And let's say the temperature of this object is given as the 10 degrees Celsius. So as you can see, between this object and this object, which object has the more internal energy? And obviously, it has to be the object with more actually a temperature. So which means this object has more internal energy, and this object has low internal energy of a system. Now, what happens if we connect the two objects? In this case, let's say we have connected the two objects. In other words, they are actually intact. This is the object of 20 degrees Celsius, and this is the object of 10 degrees Celsius. Now, because these two objects are of different temperatures, then what will happen is that there will be the transfer of internal energy. Now in this case, these objects are said to be at the thermal contact. They're said to be at thermal contact. So which means these objects are in contact and there is a transfer of internal energy between the two objects. So that's said to be at thermal contact. So now what happens is that the internal energy will be transferred from the object with high temperature to the object with the lower temperature until the temperature in both sides is the same. So that point is said to be thermal equilibrium. Thermal equilibrium. That is the point in which the objects thermal equilibrium. That is the point in which the objects has the same actually internal energy, and which is measured by the actually similar in temperature. That is how you can get it. So which means naturally, the internal energy has to be transferred from the object with more actual temperature to the object of low temperature. And what is the process is said to be referred to? Now let's be talking about what we call as the heat. So what is the heat? Now if we say a heat, this is the transfer of internal energy. If we say a heat, that is the process of transferring of internal energy between two objects due to the temperature difference. That is what we call as the heat. So heat is not a substantial thing, heat is a process. Now the process of transferring of internal energy between the two objects due to the temperature difference, that is what we call as a heat. So internal energy, flows from the object with actually more temperature to the object with low temperature. That is what we call as the heat. So keep that in mind. Now let's be talking about what we call as the Zeronth law of thermodynamics. Zeronth law of thermodynamics. Of course, we have also the laws of thermodynamics that we'll be talking about soon, but for the sake of interest, what is the Zeronth law of thermodynamics? What is the Zeronth law of thermodynamics? Anyway, but just have to understand that. So what is the Zeronth law of thermodynamics? Now let's say we have the object. Let's say this is object A, and we have, let's say this is object B, and let's say this is object C. Now according to the Zeronth law of thermodynamics, it states that if object A, it is at the thermal equilibrium with the object B, and it happens that the object B is also at the thermal equilibrium with the object C, and obviously object A and C, they are also at thermal equilibrium. So keep that in mind. What is the analog? You should have to understand that. Let's say if we have X, and X is the same as M, and let's say M is the same as, let's say, a Q, then it is an obvious thing that X is the same as Q. So that is the principle behind the actually Zeronth law of thermodynamics. Which states that if object A and B, they are at thermal equilibrium, and it happens that B and C, they are also at thermal equilibrium, it means the object A and C also has to be at thermal equilibrium. That is the principle behind the Zeronth law of thermodynamics, as you can see. So what is the measure of a temperature? So a temperature is one of the well-known physical quantities that can be measured. and the temperature can be measured. The temperature is expressed in what we call as three actually fundamental units. We have what we call as the Celsius scale, and we also have what we call as the Kelvin scale. By the way, the SI unit for Celsius scale is given as that. That is the SI unit for the Celsius scale. And the Kelvin scale, the Kelvin scale, it is given as, just been given as a K. And we also have what we call it as Fahrenheit. And which is of the SI unit, being given as F with a degree sign on top there. That is what we call it as the Fahrenheit. So let's see how we can actually express the conversions of these actually temperature scales. Sorry for the interruption there, but just have to keep on watching that. Now let's see the conversion between the Celsius scale. Let me use another key. Between the Celsius scale and should be a Kelvin scale. So how can we actually relate these actually temperature scales? Now, according to the principles behind, the relationship between these two actually temperature scales can be expressed using the formula which is given as temperature in Kelvin is equal to temperature in Celsius scale plus, that is 273.15. That is the formula that is being used. And for instance, let's say if we are to express the temperature from, let's say, a Kelvin to degree, then we just have to make this as the substitute formula. That will be expressed as being given as 270 that should just be expressed as TK minus 273.15. So that should just be given as that. And how about the relationship between the Celsius scale and Fahrenheit? So Celsius and Fahrenheit, how should we have the relationship? According to the principle behind, you should have to understand that the temperature in Fahrenheit is given as 9/5 temperature in degrees plus 32 actually a Fahrenheit degree. So should be given as that. That's the formula that is being used. So let's see how we can have the following. But actually there's no direct relationship between the Kelvin as well as the Fahrenheit. Let's say we have 20 degrees Celsius. Now how should we have this in actually Kelvin scale? How should we have this in Kelvin scale? So principle behind says that the temperature in Kelvin has to be equal to the temperature in degrees Celsius plus 273.15. So in that case, what is the TC? We have it as 20 and plus 273.15. So at the end of the day, we'll have everything in Kelvin. You should have to ignore that one as we are converting it in Kelvin scale. then you just have to sum up those. That will be the way out. And how about 20 degrees in Fahrenheit scale? How should you have it? So the principle behind, temperature in Fahrenheit is given as 9/5 temperature degree and plus 32 Fahrenheit degree. So in that case we'll have 9/5 and times 20 and plus 32 are actually Fahrenheit degree. Then you can be able to have everything that way. Now how about, let's say, if we have 50 Fahrenheit degree and due actually Kelvin? How should you have it? So first thing, we should have to express this in a Celsius scale, then or have to get it to what we get as a Kelvin scale. That would be the way out in that way. So by now you know what is internal energy of a system is all about, what is Zeronth law of thermodynamics, what is temperature, and its basic actual scales. This was just a part of review as you are preparing your exams. Thank you.